3 points x0, x1 and x2. Okay, if you have been given 3 points, so you could generate your xl0, you could generate your l1 and you could generate your l2. Okay, so in the numerator x minus x1 and x minus x2 divided by x0 minus x1 and x0 minus x2, that is the L0, because we have decided in the when we were covering the Lagrange interpolation, in the numerator if you are considering L0, so there should not be any x0 in the numerator. Okay, it should be in the denominator. So now since we are dealing with L1, so there should not be any x1 in the numerator. So L0 and x2 divided by x1, x0, x minus x2. Okay, and L2, so there should not be any x minus x0, x minus x1 divided by x2 minus x0 and x2 minus x1. So that is the review of the Lagrange interpolation, because the crucial point is only to calculate L0, L1 and L2. Okay, so if you have been given, for example, x1, x0, x1 and x2, how many points are there? 3 points. So you have been given 3 points. So out of using, if you have been given 3 points, what type of polynomial will be generated out of it? What type of polynomial? What should be the degree of the polynomial if it is generated by using 3 points? Degree 2. Okay, degree will be 2, that is called n. Okay, a second degree polynomial will be generated if you have been given 3 points. If you have been given 2 points, then linear equation will be generated. For 3 points, quadratic. For 4 points, cubic equation will be generated. Okay, so in each case you will have n. So for 2 points n is 1, for 3 points n is equal to 2, for 4 points n is equal to 3, because n is basically the order or the degree of the polynomial. So I'm just rewriting whatever is. So first of all you will write your degree and then L0, L2 1, L2 2. So here 2 is representing the degree of the polynomial and 0, 1, 2 again representing the same thing, L0, L1 and L2. Okay, because the formula is the same. Whatever the formula is the same. Whatever we have, x minus x1, x minus x2 over x0, x1 and x0, x2. Same formula. But you know, the additional thing that will be used in the Hermite interpolation is these subscript. Okay, in the Lagrange interpolation we just have L0, L1 and L2. So in Hermite interpolation we just have additional subscript which is 2, which is indicating the degree of the polynomial. Okay, that is the only. This part is the same, so that's why I'm writing only once. This part will remain the same. So it means if you have been given 3 points, so you could easily apply the Hermite interpolation because it is having the use of the Lagrange interpolation. Okay, so now we'll see that how the Lagrange interpolation is connected with the Hermite. Okay, so we'll see that. I try to make these because when you look into the formula, for example, you're looking to the formula, it is seems to be complicated, or the way you might be getting it is hard. Believe me, it's not hard. Okay, so here you just understand that it is f of x. So in any of the problem, your f of x will be given. Okay, this is f dash of x, the derivative of the same function. You have been given function and then the derivative of the function. So these two terms are very clear, function and the derivative. So one column is the function column, another column is the derivative of the same function. Now this part is the remaining. So this is depending upon n. This sum is depending upon n. So I told you n is the degree of the polynomial. Okay, so for example, if you have been given 3 points, so 0 to 2, okay, and 0 to 2, and then we have to estimate h and j of x and h hat and j, both of these. So it means that this one is crucial to estimate, these two one. And if you could see that h and j, this one, first of all, this one, the formula for this one is here, x and j, it's here. This is the formula of x and j. So x and j is 1 minus 2x minus xj into L and j. So these terms I was tried to explain you before. So n will be considering if 3 points have been given to you. So L will consider value 2 and j will be considering value 0, 1 and 2, one by one. Okay, because j is basically we have summation on it, so j will be considering value one by one, and n is again 2 and j will be 0, 1 and 2. Okay, and then so this is L and j, and L and is L square, both are the from the Lagrange interpolation derivative. Mean once you calculate the Lagrange interpolation, then you take the derivative of it. So because the Lagrange interpolation, when you apply, so you will get a quadratic equation.
You won't get x.
Yeah.
X value won't be given.
No, x value won't be given yet. Okay, then you will take the derivative of it, so you will have a linear equation. Once you take the derivative of the quadratic, you get a linear equation. So this will be a linear equation, this again will be the quadratic equation square. And then for hat, the same L and j square will be repeated here, and x minus xj. Okay, now we'll see step by step how do we calculate, because these two things are crucial to calculate. So rest we'll put into the formula and we'll see. So it's not difficult thing. So first of all, let me open the formula, the first one. Let me copy. Okay, so first of all, you have this formula, and we decided that n is 2 and j is considering value 0, 1 and 2. So first of all, we'll put 0, okay, for j. So 1 minus 2 x minus x naught and L 2 0 dash of x naught So there is no need to write this one, this part xj naught. It is understood that it's the same thing. So just to make it simple, and L square to 0. Okay, so this is expansion for the 0, and again you will calculate h2 because n will remain the same, and here it must be 1. So wherever you have put x naught, it should be now x1, L2 1 dash, L2 1 square. Okay, so next thing is 2. So 1 minus 2, x minus x2, L2 dash, L2 2 square. So now you could easily see that whatever I show you before in the Lagrange interpolation, you could simply replace here to get your h to be calculated. Okay, so your h is depending upon Lagrange interpolation. Okay, so you just have your values here, and then x will remain the same here, and x0, x1 and x2 will have the values. So you will have all together all h1, h0, h1 and h2. Okay, and similarly you will estimate the h hat. So now we will estimate the h hat. H hat to 0. So x minus x naught, L to 0 square, that is h hat 0, h2 hat 0, h2 hat 1 is x minus x1, L2 1 square, and h hat 2 to x minus x2, L2 2 square. Okay, that is the formula of h hat, this one. Okay, so the meaning is that so since you have 3 points, x0, x1, x2, so you have 3 values. So if there are 4 points, there will be 4 values. If there will be 5 points, there will be 5 h values. So I'll keep the problem simple until 3 values. It will not be more than 3 points. Okay, so until 3 points I'll keep that.
The original equation, the sum of the one before.
Yeah.
First one. Not this one. You didn't write. So it's in the book.
This one?
The one in the book, the one that has h and h hat.
Yeah, in the book. Yeah, this is the main formula. So now I'll come to this formula. Okay,
The final will give us formula.
yeah,
Final.
final. What do you mean?
You give us formulas in the final.
Yeah, I'll try, inshallah. No, for the final only. Because in final is having all the topic. In other assessment we have only single type of topics. So it's better. But it's not that difficult formulas. It's very logical formulas. Yeah. Long but logical. You just build on one logic. So let me tell you the expansion of this formula. So for example, we have summation j is equal to 0 to 2. Okay, so f of x j h n j of x. So I'll be opening first part of this formula. Okay, I'm just opening the first part. You will understand the second one as well, because second one is also having the summation. So I'll be opening the first part. So f of x naught h2 0 plus f of x1 h2 of 1 f of x2 h2 2. So this first part could be expanded by this way, because the summation sign, because of the summation sign. 1 2 3 points. So it means that you have to multiply your f of x naught with h2 0, because we have estimated h2 0 before, f of x1, but because f of x naught, f of x1 and f of x2, these will be given to you as a given column. So you will estimate h2 0, h2 1 and h2 2. When you multiply together, you will get this number, first part of the formula. Okay, and now I'm considering the second part of the formula. It should also be easy. Second part of the formula. Okay, and it is written as summation j is equal to n is to f dash of xj h hat and j is equal to f dash of x naught h hat 2 0 plus f dash of x1 h hat 2 1 plus f dash of x2 h hat of 2 2. So that is the expansion of the formula. It means that f dash of x naught, f dash of x1 and f dash of x2, so these will be given values in term of column, and these value will be used in multiplication with h2 0, h2 1 and h2 2. So what is meaning? What is the meaning? So meaning is that you have to estimate your h and h hat. That is the main. And h and h hat, these both values are depending upon Lagrange interpolations. Okay, both are depending upon the Lagrange interpolations. So just try to, I'm stopping. So here you could see that we have generated L2 0, L2 1, L2 2, okay, by using the idea of Lagrange interpolation. Okay, so these are the corresponding quadratic equations, and you could see that the coefficient of the power of the x is x square, mean 2, is degree 2. Now we have to take the derivative of each of L0, L1 and L2. So now I'm taking the derivative of the first equation, which should be 2x minus 3.5 divided by the same 0.18. Okay, and the second derivative from the second equation, again 2x minus 3.2 over minus 0.09, and the last derivative is again 2x minus 2.9 divided by 0.18. Okay, so these are the derivatives. Done. So nothing is remaining. We have derivative, we have all these values. Okay, we just need to put all these values inside the formula to get our answer. Okay, so all the terms are ready. So first thing, we need to calculate H20. Okay, H20, the formula is there. What is the formula? 1 minus 2 into x minus x naught. So x naught is 1.3. Derivative, it's here, which is equal to the L20, 2x minus 3.5, 2x minus 3.5 divided by 0.18. So derivative is multiplied, that is the derivative, and then
multiply by L square.
all together.
Yeah.
Yeah, so we could place this type of bracket. Okay, multiply by L square. So what is L square?
X square
X square
minus 3.5x
3.5x
plus 3.04
plus 3.04 divided by 0.18 whole square. So that is H20. Now here simply we'll give the values of x to get the H20. Whatever the value of x which is given, we'll put here and get H20. Okay, even you could solve the this one L20, L21 and L22 at x
Yes, but
to yeah, so you get those values, because that is needed here to have this, because we need the square as well. So that's why we are using the actual form. Okay, the square of the values. So in that case, your x,
1.5.
so f of 1.5, so which shows that x is equal to 1.5. So that is the the interpolation mean. You could see that in your x 1.5 is not mentioned, so x might be considering as a missing value. So we are using the data to estimate x, the function at 1.5. Okay, the value of the function at 1.5. So x is 1.5. One minus 2 into 1.5, 1.3, 2 into 1.5 minus 3.5 divided by 0.18, 1.5 square, 3.5 into 1.5 plus 3.04 divided by 0.18 whole square. So what is H20? should be 200 208.77. It should be, no, it should be 4 by 27.
We got 4.
4 by 27, what is the answer?
Yeah, we got something. We got 0.104. It's 4 over 27 is 0.148.
So it's way closer.
I got 0.104.
It means this is not the answer.
I'm not sure.
So you got 0 point.
0.1.
Can I have this, your calculator?
I'm not calculator. So it's step by step. Bit more. She did like that.
So it's a 3 by 5.
No,
Mhm.
look at this. I'll tell you that. See,
Let me stop the recording.
here. Step by step.
So,
Minus 5, 0 and 5.
so here the derivative. So there was little error. So the derivative will be approximated at given point. So if it is L dash 0, so it must be at x naught, and then at x1 and x2. So we have the x naught, which is 1.3 minus 3.5 divided by 0.18. So answer is minus 5. Okay, and 2 multiplied by 1.6 minus 3.2 divided by 0.09. So what is the answer here?
0.14. Here.
Yeah. And 2 into
Second one 0, third one 5.
so you must get some values here.
The second one is 0.
Second one is 0.
Second one 0. Third one 5.
Okay, so we could just check that. Okay, you just need to solve and we'll get finally 10x minus 12 and x square minus 3.5x plus 3.04 divided by 0.18 whole square. So now I think at this point you could use your calculator to get the value. 10 into 1.5 minus 12 and then 1.5 square, 3.5 into 1.5 plus 3.04 whole square, 0.18. So that is the whole square on along with 0.8. So what should be your answer now? H hat is H hat 20, x minus x naught L 20 square, isn't it? This one, is it the same formula? So it means that 1.5 minus x naught is 1.3 multiplied by 1.5 square minus we know already it is 3.5 into 1.5
minus
plus
plus 3.0
04 whole square of, okay, What is the final answer for this one? We just need to write 0.009.
So 968.
968. Okay, so we just need to test this hat if it is fine. Let me summarize. So what is needed? We have first of all the Lagrange interpolations starting from, let's say, 2 0 till whatever until 2 2, and then in the second step we have the derivative. In the third step we have the square of 2 0 and so on. And the fourth step we have h hat 2 0 and so on, sorry, h, and then at fifth position we have h hat 2 0 and so on, whatever the. So all these value will be used to approximate h2n plus 1, and where f of x multiplied by h plus f dash of x multiplied by h hat with summation sign. So that is the summary. Done.